In this video, we're going to do some recognizing rules problems. So we have recognizing rule problem 2001. Our premise is not P and Q. Our conclusion is not Q. Does any rule apply? No, in fact, no rule applies because simplification lets us go from addition lets us go to a conjunction. Simplification lets us go from a conjunction to its pieces, but it doesn't say anything about the negation of a conjunction. And not only that, but this is in fact an invalid inference. The premise says the conjunction is false. Well, the conjunction is true in only one situation, when both conjuncts are true. So if the conjunction is false, then we're not in that situation. But there are lots of ways we could not be in that situation. Both of the conjuncts could be false. The left conjunct could be false and the right true, or the right false and the left true. And so we don't have to... the premise can be true without the right conjunct being false, and so this is not a valid argument. So no good. And remember, you have to apply the rule to the whole thing, not to an interior. Let's look at 2, 3. Okay, so we have negation P and Q arrow R, and we have not P. Does any rule apply here? Well, you might think yes. You might think this is a conjunction, and whose left conjunct is not P, and whose right conjunct is if Q then R, and if that's the case, then we can infer not P with simplification. Question is which is the main connective in the premise? Is it the not, the and, or the arrow? And in fact, it's the arrow. This is a conditional, and so again, no rule applies. As this shows, this is when we restore parentheses, first we put one around the whole thing, and then we have to put one on the inside, and it has to go around the conjunction, not around the arrow. The arrow has to go higher in the tree when you're restoring parentheses, and so this is in fact a conditional, so we cannot use simplification. Let's see, 2005. So we have parenthesis, parenthesis, P, arrow, negation, parenthesis, Q, or negation S, parenthesis, parenthesis, or T, parenthesis, and S, and our conclusion is S. So if that the conjunction on the far right is the main connective, then this would be an instance of simplification, and indeed that instance on this conjunction here is the main connective, and so simplification is the rule that applies. Okay. Not P, not Q if and only if R, therefore not P and Q if and only if R. Okay, so if this is anything, it's an application of adjunction, the introduction rule for conjunctions. So is it an application of adjunction? Adjunction says if you have square and you have circle, you can write circle and square. But this is the conclusion of this is not circle and square. The conclusion of this is the negation of the conjunction. And so it's not, what we would need is not P and not Q if and only if R. So this is not an application of a rule. R and S, therefore Q or R and S. Well, it's got a new disjunction in the conclusion. So the question is whether or not any of the disjunction introduction rules apply. And if you remember what they are, it's addition. And if you think about what addition says, it says if you have one disjunct of a conditional, you can infer the conditional. So indeed, we do have the right, the premise is the right disjunct of the conclusion, and so this is in fact an instance of addition. You can put whatever you want on the other side of the disjunction because you know the side which you already have is true, and that's enough for the disjunction to be true. And this explains some parameters. So if you said you had this and you just said add, it would ask which side do you want to add on, and then it would ask what do you want to add. If you were to write add L, it would say okay, I know to add something on the left. And then when you put the slash there and put Q after, it says what do I want on the left? I want Q. So this, if you were to do this with command mode, would tell you exactly what you needed, how to apply addition, because there are options in applying addition. You can put the premise on either side of the disjunction, and you get to choose what goes on the other side of the disjunction. And this L and then the slash Q tell you what to tells you to add something to the left of the premise and what to add to the left of the premise. Okay. We have P and not Q. as our premise. We have P or Q and not Q or R. So is this a junction or addition or anything? Well, it's not an application of a junction, because a junction lets us infer a conjunction, but we need two premises. And it's not an instance of addition, because addition lets us infer a disjunction, but the conclusion is a conjunction. However, with using both through several applications of addition, if you simplified, you took the P off and then added Q to the right side of P, and you took the not Q off and added R to the right side of Q, then you'd have P or Q, and you'd also have not Q or R, and then using a junction you could put them back together. So this is a valid argument from the premise to the conclusion, but it's not an instance of any of our inference rules. Okay, P or Q, R or P or Q. This looks like an application of addition. It looks like we're adding a disjunct. But we have to be careful about the main connectives. If we think about how the parentheses come back here, there's going to be a parentheses around the R or the P, and then parentheses around the whole thing. And that means that the main connective is this or. And so to get this with addition, you'd have to have either Q, and you'd apply Q and then put R or P on the other side. Or you'd have to have R or P and then put Q on the other side. Now, you can argue from P or Q to R or P or Q, but by itself you can't get there, just with addition. Okay, P or not Q and R, not P, therefore Q and R. Well, if this is anything, it's an application of MTP, which is our elimination rule for disjunctions. That says if you have a disjunction and you have the negation of one of the disjuncts, you can infer something. But what? What can you infer? You can infer the other disjunct. And that's not what we have here. So we have P or not Q and R, and we have not P. So those are premises for MTP. But what you get from MTP is the entirety of the other disjunct. Think about it. If the disjunction is true and one of the disjuncts is false, then the other disjunct must be true. So what you should get with MTP is not Q and R, not what we have here, Q and R, as our notation says here. 17. P or Q, if P or Q, then R, not P, therefore Q. This just isn't anything. It's applying MTP to the antecedent of the conditional, and you can't do that. So, no good. So we have P or not R, arrow, double arrow, Q and not S, Q and not S, arrow, P or not R. So if we parse these, we'll see that the main connective of the premise is the biconditional, and the main connective of the conclusion is the conditional. So we think about what are our inference rules for the biconditional. It says if you have the biconditional, then you can infer the left to right biconditional. And that's not this. But we also have a rule that says if you have the biconditional, then you can infer the right to left biconditional. And then you can infer the right to left conditional. If you have the biconditional, you can infer the right to left conditional. And indeed, you can do that here. Q and not S is the right side of the biconditional. There it is there. P or not R is the left side. There it is there. So what we have on the conclusion is the right to left component of this. So this is in fact BC. And we could write BCR to tell the computer which way to go. So those are our some rule recognition problems. In the last video for this unit, I am going to do some simple Chapter 2 derivations to show you how to do some simple Chapter 2 derivations.